In this lesson, students will be able to identify the muscles that are used during cycling. How do muscles work? Thousands of thin spaghetti-like fibers make up muscle tissue. These fibers receive messages from the brain, causing the fibers to contract. The main muscles at work in cycling are the quadriceps and hamstrings in the upper leg, and the gastrocnemius and soleus in the calf. These muscles contract in a sequence that creates the pedaling action. We'll begin with the leg muscles. The hamstring refers to any one of the three posterior thigh muscles, or the tendons that make up the borders of the space behind the knee. The hamstring plays an essential role in characterizing body flexibility. The quadriceps femoris, also simply called the quadriceps or quads, is a large muscle group that includes four prevailing muscles on the front of the thigh. It is the great extensor muscle of the knee, forming a large fleshy mass which covers the front and sides of the femur. The gastrocnemius muscle, which means stomach of leg, refers to the bulging shape of the calf. It is a very powerful superficial pendant muscle that is in the back part of the lower leg. It runs from its true head just above the knee to the heel, and it is involved in standing, walking, running, jumping, and cycling. The soleus muscle is a powerful muscle in the back part of the lower leg, namely the calf. It runs from just below the knee to the heel. It is closely connected to the gastrocnemius muscle, and some anatomists consider them to be a single muscle, the triceps surae. The tibialis anterior muscle is a muscle that originates in the upper two-thirds of the lateral surface of the tibia, and it inserts into the medium cuneiform and first metatarsal bones of the foot. This muscle is mostly located near the shin. It is situated on the lateral side of the tibia. It is thick and fleshy. Now we'll talk about the muscles in the back. The erector spinae muscle is a bundle of muscles and tendons. It is paired and runs more or less vertically. It extends throughout the lumbar, thoracic and cervical regions, and lies in the groove of the side of the vertebrae column. This muscle arises from the anterior surface of a broad and thick tendon, which is attached to the medial crest. The latimus dorsi muscle, which means broadest muscle of the back, is the larger, flat, dorsolateral muscle on the trunk, posterior to the arm and partly covered by the trapezius on its medium dorsal region. This muscle is responsible for extension, adduction, transverse extension known as horizontal abduction, flexion from an extended position, and internal rotation of the shoulder joint. The teres major and minor muscles. The teres major muscle is a muscle of the upper limb and one of 6 scapulohumeral muscles. It is a thick, somewhat flattened muscle innervated by the lower subscapular nerve. The teres minor is a narrow, elongated muscle of the rotator cuff. The trapezius muscle is a large superficial muscle that has longitude extension from the occipital bone to the lower thoracic vertebrae and laterally to the spine of the scapula, otherwise known as the shoulder blade. Its functions are to move the scapulae and support the arm. The trapezius has 3 functional regions: descending, which supports the weight of the arm; intermediate region, which retracts the scapulae; and ascending part, which medially rotates and depresses the scapulae. The rhomboid muscles, which are simply called the rhomboids, are rhombus-shaped muscles associated with the scapula and are chiefly responsible for its retraction. There are two rhomboid muscles, the rhomboid major and the rhomboid minor. Next, we will learn about the shoulder muscles. The subscapularis muscle is a large triangular muscle which fills the subscapular fossa and inserts the lesser tubercle of the humerus and the front of the capsule of the shoulder joint. The deltoid anterior muscle is involved in shoulder abducted when the shoulder is externally rotated. The anterior deltoid is weak in the strict transverse flexion, but assists the pectorals major during shoulder transverse flexion, shoulder flexion. The deltoid posterior muscle is a stronger transverse extender than transverse abductor. It is strongly involved in transverse extension, particularly since the latimus dorsi is very weak in strict transverse extension. The posterior deltoid is the primary shoulder hyperextensor, since the pectorals major, nor the latimus dorsi, does not extend the shoulder beyond anatomical position. The deltoid lateral muscle. The lateral deltoid is involved in shoulder abduction when the shoulder is internally rotated. It is also involved in shoulder flexion when the shoulder is internally rotated. It is involved in shoulder transverse abduction, but it is not utilized significantly during strict transverse extension. The supraspinatus muscle. This is a relatively small muscle of the upper arm that runs from the supraspinatus fossa, superior of the scapula, to the greater tubercle of the humerus. It is one of four rotator cuff muscles and also abducts the arm at the shoulder. This muscle is the most often injured rotator cuff muscle. The inability to smooth abduct the arm against resistance may indicate a rotator injury. The final muscles that we'll talk about today are the arm muscles. The triceps brachii. The biarticulate long head of the triceps brachii enters passive insufficiently through the completion of elbow flexion when the shoulders are more flexed and abducted, or through the completion of shoulder flexion. When the shoulder is internally rotated, the ability of the long head of the triceps brachii to extend and abduct the shoulder is diminished. The shoulder must be externally rotated in order for the long head of the triceps brachii to assist shoulder abduction. The biceps brachii and the brachialis. The biceps brachii is a stronger elbow flexion when the forearm is supinated. The biceps brachii is a strong forearm supinator when the elbow is flexed. During elbow flexion, motor units in the lateral portion of the long head of the biceps are preferentially activated, whereas during forearm rotation, motor units in the medial portion are preferentially activated. The brachialis becomes more readily activated during osmometric elbow flexion. During a dynamic elbow flexion, the biceps is more readily activated than the brachialis.